In Chapter 8.3, we are going to create confidence intervals for proportions. So we're looking at problem 21 on page 388. It says sleep apnea is a disorder in which there are pauses in breathing during sleep. People with this condition must wake up frequently to breathe. In a sample of 427 people age 65 and over, 104 of them had sleep apnea. Problem A. Find the point estimate for the population proportion of those 65 and over who have sleep apnea. Well, in this particular case, we see that P hat is equal to x over n. In this case, x identifies the number of individuals who had sleep apnea, which is 104, out of the total of 427 people sampled. When we do the calculation, we get 0.244 as our p hat. We now want to construct a 99% confidence interval for the proportion of individuals over the age of 65 that have sleep apnea. If we use our calculator, we hit the stats key and we move over to test, and then we move our cursor down and we pick option 1 prop z interval, which is option A on the calculator, and then we hit enter. Then we get this screen here, and we see that it says 1 prop z interval. We enter in 104, we enter in 427, our C level is 0.99, we hit calculate. Now we get our confidence interval, and you see that the lower bound is about 19% and the upper bound is 29.7%. So if we had to do this by hand, we already have our p hat. Then we're going to calculate a margin of error. The margin of error here is equal to the z value times the square root of p hat 1 minus p hat divided by n. You may not be able to see all of that, but there it is. So our margin of error, which is also a plus or a minus, right, is going to be 2.576. That's our z value that we looked up in the table. And now we have the square root of p hat, which is 0.244 times 1 minus 2.44, which is 0.756, divided by 427, I'm sorry. All right, so now m is equal to, in this particular case, 0.0535. Okay. So our lower bound is going to be p hat, which is 0.244 minus 0.0535, and we get an about 0.1905, and our upper bound is equal to 0.244 plus 0.0535, which equals approximately 0.2975. Okay, so that's close to our estimates under this particular test. Then part B says, in another study, a medical researcher concluded that more than 9% of the elderly people have sleep apnea. Based on the above confidence interval, does it appear that more than 9% of the people age 65 and over suffer from sleep apnea? So in this case, we're asked that P is greater than 0.09, and in fact our confidence interval here shows that P 0.19 is less than P, which is less than 0.2, well actually 0.928, right? So in between that point, P is based on this particular study, and yes, right, more than 9% definitely have suffered from sleep apnea. Our second problem in chapter 8.3 is a problem 32 on page 389. A simple random sample of 300 voters was polled several months before a presidential election. One question was asked, are you satisfied with the choice of candidates for president? A total of 123 of them said they were not satisfied. Construct a 99% confidence interval for the proportion of voters who are not satisfied with the choice of presidential candidates. Well, if we were doing this by the calculator, we of course would enter in stats, then test, and come over to one proportion z interval. We would enter 123 for x, and n is 300. Our C level is 0.99. We hit calculate, and we see that in fact our confidence interval is about 34% to 48% are not satisfied with their choices of presidential candidates. If we were to do this by hand, again, P hat, when we calculated it, was again 123 divided by 300, and that gave us 0.41. Now we want to calculate the margin of error. The margin of error is equal to z divided by the square root of P hat 1 minus P hat over n, right? And so our m, which is also a plus or minus situation, right, is equal to, again, 2.576 times the square root of 0.41 times 0.59 divided by 300. Here we get a margin of error of 0.0731. So our lower bound estimate is going to be 0.41 minus 0.0731, right, which is equal to 0.3337, and our upper bound is equal to 0.41 plus 0.0731, which is approximately equal to 0.483. So there's our upper and lower bound. In our second question, it says among the 300 voters were 158 women. These constitute a simple random sample of women voters. If this sample were used to construct a 99% confidence interval for the proportion of voters who are satisfied with the choice of candidate for president, is it likely that the margin of error would be larger, smaller, about the same as in part A? Well, if we assume P for unsatisfied is the same as the above point estimate, we find that the number of voters that were satisfied from the 158 is 93. So what we do is we calculate a new p hat of satisfied, which is 93 over 158, and we plug this information to our margin of error, and we get a margin of error of 0.1001, which is larger than our margin of error of 0.0731. So in this case, it is larger. That concludes our problems in chapter 8.3. We will talk about sample size in class. So we're finished with similar problems in 8.3.